Montreal. Today I'm going to tell you about a meta-analysis we're doing on green roofs, and specifically looking at cooling. But before we can talk about cooling, it's important to talk about warming. And here's a graph we're all too familiar with on the urban heat island effect. And it's no surprise that cities are warmer than rural areas. But as more than half the world's moving into urban populations, over 80% of Canadians, and even 60% of Manitobans, it's important that we look at urban heat island research and focus more on urban ecology within cities, and especially on heating and climate change. So we learned yesterday a lot about parks and how trees can help cool environments. But what if we could retrofit these green roofs, green infrastructure, on our buildings, onto the built environment to help with cooling? So this is a weapon here. Green infrastructure not only helps with stormwater management, air quality, or cooling the buildings themselves, but what's often overlooked and under-researched is how green roofs can help cool cities as a whole. So this raises two questions. What is the cooling effect of green roofs around the world, as well as where are they most beneficial? Not in terms of economic value, but in terms of just cooling. To do this, we looked at literature published over the last 10 years, looking at just one simple variable, well, one of many, temperature difference. So this is the temperature above control roofs, which is your regular roof, cement, concrete, gravel, and also looking at the temperature above green roofs. And a positive number from here would mean that it would be cooling, green roofs are colder, and warming would be where the control roofs are actually colder than the green roofs. So we put a search string through 3 different databases and came out with about 1,700 studies. But after going through criteria, removing duplicates, we really had around 29 studies to deal with 102 data sets. But these papers were found from around the world, as far west as Vancouver, as far east as Sydney, Australia, with a large concentration around Western Europe, as well as Eastern Asia. Types of different data we collected was mainly climate, to differentiate from paper to paper, but also, as one of the graphs here taken from one of the papers in the meta-analysis, we looked at different types of vegetation, the height measured, how deep the substrate is of the green roof, as well as the roof area, amongst other variables, but this is just one of the examples. When we look at how the data is actually distributed, we see that a large proportion of it's in summertime. And when we actually zoom into that summertime data, we see most of it's only between 2 different climate zones. And these 2 climate zones, subtropical CFA and CWA, are mostly in Hong Kong and in Eastern Asia, with oceanic being around Northern Europe. When we actually plot this, we see that there is a significant cooling effect across these 4 different climate zones that most of the data is found in, but there's a lot of variance between especially humid subtropical regions as well as the rest, but a lot for these as well. When we just look at, for example, oceanic climates, where we keep in consideration moderator variables like the height that's recorded at, or whether there's a water treatment, we see that despite there not being statistically significant enough results, we see with large trends of warming and cooling amongst different seasons. Example here, we see in winter there's actually a warming effect. Green roofs are warmer than regular roofs compared to summertime, where green roofs exhibit a cooling effect. So let's go back to our 2 questions. What is the cooling effect of green roofs around the world, and where are they most beneficial? If we look at just the abstract number, we can say, yeah, it's about 0.73 degrees Celsius, but with not taking into consideration all the variables that come into play for green roofs. And that also leads to kind of an inconclusive of where they're most beneficial, despite them being more cooling in warmer climates. But this just asks more questions. So in our next steps of our research, we're looking at different factors that would affect each individual study, looking at vegetation, substrate depth, how they all correlate, and constructing a model to see how these variables would affect temperature difference on green roofs. And with that, I thank you guys for attending. The NSERC Design House Great team and my amazing lab mates. You've been ready. Yes.
So I don't know if you can answer this, but in any of these meta-analyses, did they look at the cost of building and maintaining green roofs versus the potential cost of leading to the community for the building?
Yeah. So it's not something we looked at specifically in this, but there were a lot of papers that discussed it. There's a lot of elements that come into play when looking at the cost of green roofs. Not only like you can't put a green roof on a roof, it costs a lot of money for the structure, but also a lot of money for maintenance, as well as heating and cooling. So sometimes, like I mentioned, the warming effect is actually beneficial if you're spending more carbon emissions and more money heating buildings during the winter time when it's colder compared to just having a regular roof. But it is something that is being more and more discussed, more so than cooling effect when looking at beneficial green roofs. But yeah, something definitely look at.
Cool. We'll leave it there and let Bruno.